Welcome everyone. So today we will be learning about 8051 microcontroller and its input output ports. Okay, so today we will learn about its input output ports. So 8051 have four input output ports P0, P1, P2 and P3. Each port of 8 bits. 8-bit means like P0 it is from 0 to 7 and P1, P2, P3 are all are the same. So 8 into 4 is equal to 32 input output pins. Okay, so there are 32 input output pins in 8051, which allows the microcontroller to connect with the other peripheral devices. That means other peripheral devices such as which are giving input or which are receiving the output. Now let's see the pin configuration. That is, the pin can be configured as 1 for input. Okay, so like whenever the port 0 is 1, whenever the port 0 is equal to 1, then that port will take input. Then we can give input through that port. And whenever the port is 1, okay, whenever the port is 1, so in that case we can give output through that port. So that is what written. Sorry. Whenever a port is 0, then we can give output. So and 0 for output as per the logic state. Okay. So let's see the input output pin. All the circuits within the microcontroller must be connected to one of its pins ex except port 0. Why port 0? Because it does not have a pull-up resistors built in. Uh, if you're confused about the pull-up resistor, let me explain you. As you can see that this port 0, it does not have any pull-up resistor. So what is a pull-up resistor? As you can see this here, if there is no pull-up resistor, if there is no pull-up when switch is open, the input is floating state. Okay, so see, as you can see, this button is open. If there is no pull-up and the input switch is open, then that is in floating state, which means it is neither 0 nor 1. Okay, it is neither 0 nor 1. That means that port cannot act as an output or as an input port. Okay, so now if now if you use a pull-up resistor, which is usually around 10k, this resistor is around 10k. Okay, this register is around 10k. So when switch is open, the input is connected to VCC. When we open the switch, when we use the first of all, when we use the pull-up resistor, and then if we open the switch, then it is connected to VCC. Let me show you here. This VCC, okay. Whenever we connect a pull-up resistor to this port 0, then whenever we open the switch, it is connected to this VCC. And whenever we close, whenever we, if the switch is closed, the input reads low because no current flows into the input pin. Whenever the switch is closed, whenever this switch is closed or attached, then this input reads low, which means 0. So 0 means giving the output, so no data or current will be flowing into the microcontroller. Okay, so uh, let's see the input configuration and output configuration. Input configuration: if any pin of this port is configured as an input, then it acts as if it floats. That is, here this is the meaning of float. The input has unlimited input resistance and indeterminate potential. What does that mean? As I have told you that whenever we are giving the input, all the ports except P0 are connected to pull-up resistor, and whenever we are taking the input, then it is whenever we are taking as an input, then it acts as float. Okay, because when we are taking the input, then the pull-up resistor is used. So what is output configuration? When the pin is configured as an output, then it acts as an open drain. So what does open drain mean? Whenever we are using input configuration, then the data is coming from input devices to our microcontroller, and then only the pull-up resistor is coming in work. Okay, and whenever we are sending the data to any output, sending the data as output, then that pin act as an open drain, which means we are applying logic 0 to that port. Okay, and applying logic 0 to that port means that port must be acting as output. Okay, so by applying logic 0 to that port bit, the appropriate pin will be connected to the ground 0 volt. So this is also an important point. Whenever you are giving input, then pull up register will come in work, and then it will be connected to VCC. And whenever we are giving the output, then it will connect to ground because it is an open drain. Okay, so in order to apply logic 1, which is of 5 volt on this output pin, it is necessary to build an external pull-up resistor for port 0. Okay, because port 0 doesn't have any external build, port 0 doesn't have any built-in pull-up resistor, so we have to add an external pull-up resistor for in the case of port 0. So now let's see each and every port and what are their work. Like port 0, as we have talked, port 0 port is characterized by two functions. When the external memory is used, then the lower address byte is applied on it. Else, all bytes of this port are configured as input-output port. So let's go back to the diagram. We are talking about port 0. So whenever we are connecting an external memory. So in any case that we are running an instruction and our internal memory runs out, so we have to connect an external memory. Okay. So whenever we are connecting an external memory, this port 0, this port 0 will this port 0 will have to address, let's see, this port 0, the external memory is used, then the lower address bit is applied. Then the addresses that is present in port 0 from 0 to 7, those are applied whenever we are using the external memory. Else all bits as a, if we are not using any external memory, then all work as an input output port, simple input output port. And the second point is when P0 port is configured as an output, then other ports consisting of the pins with built-in pull-up resistor connected by the end of 5 volt power supply. The pins of this port have the resistors left out. So whenever this P0 is acting as output, then it is connected to ground, as I've told you in the previous slide, and acting as an open drain. So whenever it is acting as an open drain, all the other ports, which is P1, P2, and P3, will be connected to 5 volt and having resistors left out. Now port 2, port 1. So port 1 is a true input output port, as it doesn't have any alternative function as in port 0. Uh, but this port can be configured as general input output only. It has a built-in pull-up resistor and is completely compatible with TTL circuits. TTL circuit is transistor logic. Okay, so let's see. Whenever we are using port 1, this port 1 is simple input output port. It doesn't have any other functions to perform. Like in port 0, it has address and data bus. In port 2, it has only address bus. And port 3 has different other functions like timer, external interrupts, transmission, receiver, read write function. Like the any of these, port 1 only function is to provide input and output. Okay, now let's see port 2. Now port 2 is similar to P0. This P0, okay, P0. When the external memory is used, whenever we are using the external memory, then it port 2 will act same as port 0. The only difference is in port 0 we were accessing the lower address byte, which is A0 to A7, but in port 2 we will be accessing or occupy the higher address bytes, which is from A18 to A15. How A18 to A15? As you can see, there are 16 address buses. Okay, how 8 address buses are present here and another 8 bus address are present here. So whenever we are using an external memory, this port 2 will occupy higher address bus, which is from A8 to A15. Okay, now uh, when no memory is added, then this port can be used as a general. This is also same as port 0. When there is no memory added, then it will also be used as simple input output port. Now let's talk about port 3. Port 3, it is a port that functions similar to the other ports, except that the logic 1 was for input. Okay, logic 1 was for input. It must be applied to appropriate bit of P3 register. Huh. That is same as whenever we are getting the input, there is some resistance present there. and whenever we are sending the output, that becomes an open drain, and open drain means flow. So, what did we learn in today's video? We learned about various input output ports. We learn about input output ports. We learned about pull up resistors. We learned about port 0, port 1, port 2, and port 3. Okay, so that's it for today's video. Uh, we'll meet in the next one.